In this video, we're going to talk about equivalent trigonometric functions. Specifically, we're going to talk about the cofunction identities. The cofunction identities say that the sine of theta is equal to the cosine of pi over 2 minus theta, the cosine of theta is equal to the sine of pi over 2 minus theta, and the tan of theta is equal to the cotangent of pi over 2 minus theta. Well, these cofunction identities make a lot of sense if you think about the unit circle. Let's imagine for a second that theta is equal to 10 degrees. If that was true, we would have a terminal arm right about here, and we would see that the length of that vertical side is equal to the y-coordinate. And that y-coordinate is equal to the sine of theta. Okay? Now, if we want, instead of putting it there, we can put it over here on the y-axis. Okay? So we'll think of that, this line right here on the y-axis as being the sine of theta. Now, let's think of pi over 2 minus theta. Well, pi over 2 is the same as 90 degrees. And we've said theta for this example is 10 degrees. So if we imagine pi over 2 minus theta, we'd be imagining the angle of 80 degrees. Well, an angle of 80 degrees is going to have a terminal arm right about here. Okay? So that terminal arm has an x-coordinate equal to the length of this horizontal line. That horizontal line is equal to the x-coordinate, and the x-coordinate is equal to the cosine of whatever the angle of that terminal arm is, which in this case is pi over 2 minus theta. Well, we can move that horizontal line that we just drew down to the x-axis to get a better idea of what the length of that horizontal line is. And that length of that horizontal line, like we just said, would be the cosine of pi over 2 minus theta. Well, if we compare this, the length of that vertical arm right there with the length of that horizontal arm right there, we see that the sine of theta is equal to the cosine of pi over 2 minus theta. So using that type of thinking, that's how we're going to establish our cofunction identities. So let's look at some more of these things here. Let's look more generally. Imagine that we've got theta indicated by the lower terminal arm and pi over 2 minus theta indicated by the upper terminal arm. Now, of course, if theta is the upper terminal arm and pi over 2 minus theta is the lower terminal arm, all of these relationships will still hold. But for this example, we'll use the diagram that we've drawn. Now, if we sketch across from the the top of the terminal arm for theta, and we establish the y value of that, we'll get the length of that vertical side. And if we look at the terminal arm for pi over 2 minus theta, and then determine the x-coordinate of that, we'll get the length of this horizontal line. And what we're saying here is that if you think about it, based on the symmetry of a circle, the x value of pi over 2 minus theta will be equal to the y value of theta. Well, that is code for saying the cos of pi over 2 minus theta will equal sine theta. And of course, it works the other way as well. If we look at the lower terminal arm, which we've called theta, if we look at its x-coordinate, and then the upper terminal arm, which for us is pi over 2 minus theta, and we look at its y-coordinate, we'll see that that relationship holds true as well. We'll see that the x value of theta, the horizontal side, and the y value of pi over 2 minus theta, the vertical side, are equal. And that's code for saying that the cosine of theta is equal to the sine of pi over 2 minus theta. And both of these relationships we've just established will be true regardless of what quadrant we're in, and hopefully you'll trust us on that. And it's perhaps a little easier to see this relationship if we use a known triangle. Many of us know SOHCAHTOA. If you don't worry about it. But if you know SOHCAHTOA, one of the triangles that we see a lot is what's called a 30-60-90 triangle. And in the 30, 60, 90 triangle, the side lengths are in the proportion you see here. So this is a very possible triangle. Now, if I look at the sine of 30 using SOHCAHTOA, then what I would be looking at is the length of the opposite side over the hypotenuse. Well, the opposite side for 30 would be 1, and the hypotenuse, of course, would be 2. Now, compare that to the cosine of 60, i.e., the cosine of pi over 2 minus 30, 90 minus 30. Well, the cosine of 60 is, we look at the angle 60 and we look at the adjacent over the hypotenuse. And when we look at that, we see that the cosine of 60 degrees is also 1/2. So letting theta be 30 degrees and remembering that pi over 2 is really just the same as 90 degrees, we see that the sine of theta actually equals the cosine of pi over 2 minus theta. And the relationship will hold true if we consider cosine of theta and the sine of pi over 2 minus theta. And finally, let's look at the relationship for tan theta. Well, to do this, we're going to look at our trig identities that we know so well. We know that tan theta is equal to sine theta over cos theta. But we've just established that the sine of theta is equal to the cos of pi over 2 minus theta, and that the cos of theta is equal to the sine of pi over 2 minus theta. Now, if you look at this second line right here, we have the same angle in numerator and denominator, and we've got cos over sine. So what we really have is the cotangent of that angle, which is the cotangent of pi over 2 minus theta. So we've just established that on this slide that the tan of theta is equal to the cotangent of pi over 2 minus theta. And so putting all the identities together that we've talked about, we've established these three, which are called the cofunction identities.